So again, we're just going to talk about the blue one, weathering today at Smile, and then Wednesday we'll get to the final two steps, moving it and then dumping it somewhere else. So weathering is the breakdown of rock into smaller pieces. Some of you use this word for camel rock, which is, yeah, that's true. It's not really a specific explanation of what's happening, but it is being broken down over time. Some things that cause weathering are water, wind, ice, chemicals, and organisms. Again, people can break things down. So if you've ever seen like some really old statues, if you've been to even some parts of the United States where they have old statues, you'll see that the rock and the statues, which are made of rock, do not stay the same over time. That they change, and that's what we're talking about this week. Today we're just going to look at mechanical weathering, which is when things are physically broken down. They are being pounded, they are being beat down, things are crashing against them and forcing them to break. So it's kind of like taking a hammer to a rock. That is an example of mechanical weathering. And although like wind doesn't have a hammer, it acts in a very similar way. If wind hits something long enough and breaks against it for long enough, then the rock will start to fall apart. So that is known as mechanical weathering, physically breaking it down, wearing it down, often with things crashing or running into it, just impacting it over and over and over again. Kind of the most classic example of this is frost wedging. Something really unique about ice is that it doesn't follow the pattern of most molecules. Most molecules, as they get cold, do they get further apart or closer together? Closer together. So most things, as you take the energy away, they go from gas, which is far apart, to liquid, to solid. They get closer and closer and closer together. And water does that until a point. And then right when you hit, what's the freezing temperature of water? 32. Right when you hit 32 degrees, water does something really unique. It pop and locks. If you look here, here is water that is a liquid, here is ice that is a solid. And ice has this very unique shape. If I draw, kind of tracing where those molecules are going. What shape is that?
A diamond.
Yeah, it's a diamond. It's a hexagon. A diamond's actually a really good connection because it's a crystal. Water forms a crystal. Obviously, we know crystals are rare, right? We spend a lot of money for our gemstones and our jewelry because crystals are not very common, and that's why they're expensive. We're not spending a lot of money on water crystal, aka ice, but it is unique in that it does form that crystal pattern. And so it gets closer and closer and closer together until it hits 32 degrees, and then it pops into this really unique pattern called a crystal. And because of that, water is actually less dense. It needs more space when it's a solid, which is very, 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 very uncommon. So I like to think of it as it gets colder and colder, it's huddling down, and then all of a sudden when it reaches 32 degrees, it just pops. And when it does that, it elbows out and it forces things apart. It's less dense, and so it pushes things away. And that is why frost wedging is possible. That because it takes up more space as a solid, it actually is pushing the rock apart. Water seeps into the cracks. Then when it freezes, it tries to do that pop and lock thing, and it will push until it is able to get into that crystal, and that's why it's able to force rock apart. If you think of, millions and trillions and billions of tiny little atoms trying to do this, basically elbowing their way into that crystal, like I like to say pop and lock in, it takes up more space, it's less dense, and that's why frost wedging is a really powerful tool. The fact that water just freezes and it looks different when it freezes is how water is able to break apart rock when it goes from a liquid to a solid. Right, another type of mechanical weathering is abrasion, just things crashing into each other. Wind and water do this all the time. How do river rocks compare to normal rocks? Have you ever looked at like rocks in a river or bought river rocks at like a gardening center to decorate your driveway? They're softer, they're smoother, they're often kind of round. They look like the perfect rock. They're not all jagged and pointy, they're very rounded. That's because the water over time, kind of like sandpaper, has slowly curved that surface to make it as smooth as possible. Wind does the same thing. Over time, wind makes things soft because all of that wind carries sand crashing into it, and it starts to take off those little jagged pieces of rock until the rock is left nice and smooth. So this is what happens here. We water is not as powerful of a agent of change here in Rio Rancho because we don't get that much water except for like monsoon season, and then you can have a big change really quickly. But for the most part, it's abrasion and it's wind. Because we're in a desert, things are really dry. We don't really think about the wind being really powerful, but the wind is basically like sandpaper, right? We saw this the last couple weeks with all this crazy amount of wind that we've been having. Sometimes it's like almost hard to make out the mountain, even though it's huge right there, because all of that dust and stuff that the wind is carrying with it. And so it can be a powerful agent of change, especially when it's going really fast. So on a small scale, abrasion leads to smooth rock, like a river or wind smoothing the desert rocks over time. On a large scale, abrasion could be something like a ginormous piece of ice, like a glacier, which is literally carving or taking off sides of mountains as it moves. To understand mechanical weathering a little bit more, we're going to do an experiment here together. Again, here in Rio Rancho, the biggest agent of change is wind because we don't have as much water being in a desert. So we're going to model that with the containers. They are glass, so please don't put them near the edge of the table. Be careful with them. In there you have some salt, which is like our sand. It's like our abrasive material. And you also have some chalk. The chalk is meant to model a rock. So check out your chalk in the way that it looks now. Carefully pass it around so that everyone can see kind of what it is looking like as we start out. You pass the jar around or make sure that everybody has a chance to look at it. You do not need to open it up. Take a look at the
Is this salt and chalk?
What is that?
Oh, it is salt. Here, check it out. Motherfucker. Just throw it.
Just
Pass.
open it up and go.
Nah,
Alright, so now we need to mimic physical
Eat the salt.
weathering or
Eat the salt.
mechanical weathering.
Here,
So we
pass
are
it.
going to make
Pass
some
it.
wind. We are going to shake the container.
Here.
We're going to have everybody at your table do it for 1 minute. If you have a team
Oh,
of
I
3
asked
or
you.
2, you might
I asked
need
you.
to take an extra turn.
I'll do
So
it.
please pass the jar to the first
Let me
person.
do it.
And
Let's
again,
do
you're
it,
going to
let me
shake
do it.
it.
Let's
There's
shake it.
no right or wrong way to do this.
Let's shake it,
Wind
let's
is
shake it.
never exactly the same.
Let's shake
anyway.
it.
And we're going to start
Let
a
me do
minute
it.
timer, and I'll let you
Please.
know when to pass to the next
Let's shake
person.
it.
All
Let me
right.
do it.
And then you'll do it after her.
I have a funny way to do it.
Shake that container.
Just shake it for a minute.
I have a funny way to do it.
Any way that
I
you
have a
want.
funny way
Shake it
though.
up
It's a
halfway
really funny
through.
way how I
There's
do
no
it.
right or
After
wrong.
she's done,
Like I
it's a
said,
funny
wind
way
is
that I
not
wanna do
always
it.
consistent either,
So-
so you don't need to be when you model wind.
so everybody's doing it?
Yep, we're
Oh.
gonna give everyone a shot, so if you're making fun of someone for their technique right now, don't worry, you're next.
What did you do? What you do?
We're about halfway done, so that first. Some of you are more aggressive than others.
Well, I'm going to be very aggressive. I'm going to shake it, huh?
I really don't.
I don't know how I'm going to do it. I don't even know.
Good question.
I don't know what's going to happen. It's like,
Dude, the salt is turning yellow.
Alright,
Alright,
you
okay.
pass it to the next person.
let's go.
She's like, I'm so over this.
Here we go, 1 minute on the clock, go ahead and start.
You knocked yourself out. I'm like, so hard.
Oh my god.
That's what steroids look like. Dude, if you have wind like
Oh,
You
jeez.
are like hurricanes, others nothing much.
I broke it.
Oh, we got a tornado.
I wrote the system.
I want to die, I want to die.
you're not, yeah, no. Are you a child?
Bro, it's breaking. Look at that. Alright, I'm done. Hey, yo.
It's my turn.
It's like yellow now.
Bro, you would literally.
that.
Any changes? Take a
I did not even
minute
mean to do that.
to just kind of observe, see if there's any noticeable changes.
Oh my god. I did not even mean to do that, bro. I did not even. Mine's yellow. I did not even mean to do all that. Bro. I did not even mean to do that. Oh my god. Bro. Hey, Alex.
That probably looks really bad.
Shake it till you can't no more. I don't even know how I made that change. That fast like that. I was just doing it very aggressively. That's why it's that color.
Did you not eat your phone? Did you chicken? Emma, you cannot eat your phone?
Bro. Did you even expect it to make that change when I did it? You didn't expect that?
What?
Did you expect it when I shook it to make that change? You expected it to make that change when I was doing it like that? Like how it was like going around? Cap. You did not expect it. Alright, your turn, buddy.
I didn't expect
You're
it.
crazy.
What is this, chalk?
Yes, it's chalk.
Here's our last
Duh. Ow. Alright, buddy. Go crazy. Crazy, crazy. Ow, fuck.
Oh.
Oh, there's a timer. I said if it goes back around, I'm gonna break the chalk again.
Did you eat the salt?
No. Hell no. And you ain't gave me $1 million, I wouldn't do it.
For a million?
If you ain't have $1 million, I might. But I'm not too sure. Dude, looks suspicious.
This kind of feels like we're just making a really crappy art project.
This is exactly what this is. No,
Go
no.
crazy again.
Okay.
Weathering is done. Please take a minute and
Oh, whoa.
share that around the table. Observe that chalk carefully and any changes that may have occurred during our shaking process.
She said explorer.
I observed no. Hey, wait. Close it. There, now observe
We're
it.
gonna have you come to the front one team at a time. Please take the pieces of chalk out and then pour the sand into the container. Doesn't matter to me what order you want to come up. Just
Oh, Jesus.
start coming on down, one at a time.
It's smoking.
Is it?
Great.
Oh,
Again, with
shit.
those pieces of chalk, take a look at them. See if there's been any changes to them over the last few minutes.
Yup.
And again, I'm looking
Definitely.
for you to come to the front and pour your chalk
Maybe because you broke
dust
it.
into
Yep.
the container.
I didn't break it. It weathered. I didn't break it.
You're good. That's what I knew about. All right, green team, I have their powder. I need the rest of yours, please.
Oh my gosh, is it gonna be so much?
Yeah, go ahead and just put the chalk back in the jar.
Okay, take the chalk out.
I did.
Well, hurry up.
Lord, it's already out. There.
Well, go put it
I'll
in
shake it. I'm just kidding.
the-
Alright. Hang on. Save the chalk.
Yo, Daniel,
It's yellow, bro. Oh, shoot.
And then if you could just put the chalk back in the empty jar, thank you.
Don't expect me to break it because I will. No, I'm just kidding.
Thank you. All right, we made some beautiful sand art here. So I'd like you to take a minute and think about, discuss these two questions. What happened to the chalk as it physically weathered? Does the
broke.
chalk look any different?
It broke.
We got one team. Does the chalk look any different now than when it started? And
Wow.
what do you think could happen if particles built up over time. What do you think happens if this happens in the real world and particles build up over time?
Are you okay?
Okay.
It feels smooth, feel it.
We are here at 10:06. It's 10:06.
Can I go to the bathroom?
As easy as that. Wow. Dude, did you hear that? Wow. I'm a god at making that sound. Wow. Why easy?
No, it's just a
Surprise.
because this end became
Go.
the green of the top.
Alright, give me a scary movie character impression.
What?
Give me a scary movie character that I should do an impression of.
You want me to give you one?
Yeah, give me a like a
Alex, can you please share with
just someone that I can do an impression of that's a scary movie.
Chucky.
Chucky? Which version? The one where he's a child play, like a real doll, or when he's walking around.
He's walking around.
So
Looks
isn't
like you
it,
guys
right?
want to talk, so can you please tell us what you noticed about how the chalk has changed?
Well, it breaks down every time you shake it.
Okay. And Alex noticed that that meant that it had gotten a little bit smaller. Jeremy, what else did you notice? There's some little holes in it. Any other changes that we noticed? The sides are smaller. So now we can see how, again, that abrasion process works. We talked about river rocks being smooth. The same thing happens when wind breaks down things over time. It's not so much the wind itself, the fact that the air is moving, but the stuff that it's carrying with it. So here in Rio Rancho, the same thing is happening over time to everything here because we have a lot of particles in the air. Whether it's the sidewalk outside or the Sandia Mountain, the wind is slowly breaking down the rock in the same way, as you guys said, making it smaller, making it smoother, putting little holes and cracks and dents into it through that same process. At the end, we actually did more steps. We practiced what would happen if that rock not only broke down, but it got transported to somewhere else and built up over time. So what happened? Sand dunes could happen for sure. In this case, we have more than one type of rock though, so when it builds up over time, what do we see? Yeah, we see color, and how do you know that there's more than one type of rock layered there? The color? That there's colors and that there's multiple layers. So if you've ever seen rock like this, where you can see the layers in it, that's exactly what happens when that rock is not only broken down, but transported somewhere else and then hardens into forming new rock over time. So we'll talk about that later in the unit, but again, that just shows you what happens when things break down. All right, so finishing up today, we are going to do a $2 summary. Instead of you answering lab questions, you're going to summarize what you learned with exactly 20 words. So the idea of the words costing money comes from like people writing articles online. We don't worry about length of stuff so much anymore, but back in the old day when people used to print, every word cost money. So every word in this case is costing 10 cents. You have 20 words exactly. If you give me an extra word or you leave off a word, I will take off a point or two because I'm looking for you to challenge yourself to get exactly 20. What I would like you to write a summary of is what you learned from our little lab that we did today. So summarizing, you need to have it specifically talk about physically weathering, about abrasion, which is this process of the wind or water breaking down things over time. That is your topic. And again, I'm looking for you to write exactly 20 words of what you learned. Some students find it useful just to open up a random document or at the bottom of their notes, kind of brainstorm and write it out there. You're welcome to brainstorm on the back or kind of rough draft on the back as well. Or you can even use your whiteboard. I'm fine with that as long as everybody has different answers. You have the rest of class. I'm looking for exactly 20 words and they need to make sense. Obviously not just like random words like rock,
Another scary movie.
wind.
What?
Another one.
And
Another
again, your
impression.
topic is mechanical
Jason.
weathering. What you
Who?
observe
Jason.
or what you
Jason?
learned today
You
about
Jason
how
Voorhees?
rock can be broken down by wind, by rain, etc.
How's that?
If you want to make it in a random document, that's fine.
Who's
You're
next?
turning it in on a piece of paper though. And as always, there's pencils on the side if you need
She doesn't
something.
make sound, does she?
So you have the rest of class to write your 20-word, exactly 20-word summary
Are you serious?
on abrasion or mechanical weathering. You can write what you observed with the chalk and
Oh,
why it
dropped it,
happened.
sorry. Here.
Passing them out, they're small little half sheets between the center and the center. Alright, so you have 10 minutes to write.
Oh yeah,
20
Annabelle
words, I
doesn't do
believe.
sounds. Hey buddy, I just learned that Annabelle doesn't make any sounds. She just moves around. So who's next? Ghostface.
Okay.
Surprise.
Nice.
I am. What else can I do?
If you're not sure where to start, that's where maybe just like typing it out and kind of rough drafting it that way can be useful. Or you're welcome to use that whiteboard too.
Oh my lord. Yeah, 20 words. Let's have 20 words.
We are writing a 20-word summary on what we learned from the lab about abrasion,
Okay.
mechanical weathering, how winds and things break down.